Sometimes due to manufacturing defects or due to the wear and tear of the screw threads, there may be rising irregular gaps or increased gaps for the screw gauge. Thus, the screw gauge may be subjected to contain a type of error known as the zero error. Sometimes in a given screw gauge, when the screw completely touches the fixed stud, but the zero of the circular scale does not coincide with the reference line, then such an instrument is said to contain the zero error. To find out the zero error, the position of the zero of the circular or the head scale with respect to the reference line is observed. First, the screw gauge is vertically positioned with its U-shaped frame at the bottom and the ratchet at the top. Observe this example. Here, the zero of the circular scale is to the right of the reference line of the linear scale. It can be inferred that the screw gauge is already measuring a certain distance. This is a flaw. Thus, we can say that the screw gauge is measuring an extra length, and hence this extra length should be subtracted from the observed length to obtain the actual length. This type of error, in which the zero of the circular scale is to the right of the reference line of the linear scale, is called as the positive error, and the correction we make is the negative. Here, in this case, fourth division of the circular scale coincides with the reference line. Thus, the extra length it measures is 4 into 0.01 millimeter. Hence, the correction should be minus 4 into 0.01 millimeter. Similarly, in a screw gauge, if the zero of the circular scale is to the left of the reference line, then the device is measuring less distance than the actual length. Therefore, this distance is added to the observed length to obtain the actual length. This type of error is called negative zero error, and the correction is positive. Here, in this case, the 45th division of the circular scale coincides with the reference line. Therefore, the zero error is 5 into 0.01 millimeter, and the correction is plus 5 into 0.01 millimeter. Let us summarize our understanding on zero error. Move the spindle of the micrometer until it touches the anvil or check pin. If the zero mark on the thimble is not aligned with the zero of the datum line of the sleeve, the micrometer is said to have zero error. If the micrometer reads plus, it has a minus zero error. The error will have to be subtracted from the actual reading. If the micrometer reads minus, it has plus zero error. The error will have to be added to the actual reading. Click next to proceed to the next screen.